So the second part, the second objective of the day, finding the equation of the tangent by implicit differentiation. The difference between this equation here and the previous one is that the right side of the equal sign here has not only the constant, not only 3, not only 4, it has also negative 4y. It has a function of y as well. So now derive, just like what we do every single time, implicit differentiation means we derive everything here, both sides of the equation. So I'll derive first x squared times y squared, and that is a product rule because these are two functions multiplied. So I'll get the derivative of the first one, which is 2x, second one as it is, y squared, plus first one as it is, which is x squared, derivative of the second. Derivative of y squared is 2y, and then we said we always multiply whenever we derive something that has a y, we always multiply by y prime. All of this is just the derivative of the first part. Now the derivative of negative 2x is just negative 2 equals to the derivative of 4, 0. Derivative of negative 4y is negative 4, and we said we multiply by the derivative of y, or y prime in that case. The second step is we move everything that has a factor of y prime to one side and everything else to the other side, which means I need to have this and this on one side and everything else on the other side. So I'll write down the x squared 2y y prime on this side. I'll move the negative 4y prime to this side as positive 4y prime equal to the 0. There's no need to write that one down, but we'll move 2xy squared to this side and negative 2 to that side. So I'll have negative 2xy squared plus 2. Once we've reached this step here, we need to solve for y prime, so I need to take y prime as a common factor. So here it is, y prime, open a bracket, x squared 2y plus 4. All of this is equal to negative 2xy squared plus 2. Again, I'm solving for y prime, so I'll move this bracket to the other side by division. So y prime is equal negative 2xy squared plus 2. And all of this is then divided by the bracket as it is, which is x squared 2y plus 4. I've got the first part of the question, which is finding y prime. The second part of the question is to find the tangent, the equation of the tangent at 2 and negative 2. Alright, so to find the equation of a line, we need to find the slope. So the first thing I'll do is to substitute the 2, which is the x value, in the derivative to find the slope, and the negative 2, which is the y value here as well, in order to calculate the slope. So negative 2, instead of the x I'll put 2, instead of the y I'll put negative 2 squared plus 2. All of this is over, instead of the x substitute 2, and then 2 instead of the y, negative 2 plus 4. Calculate this thing on your calculator. So together this should be, I'm doing it now, negative 14 over negative 12. Okay, so negative 14 divided by negative 12 is positive 7 over 6. So my slope is 7 over 6. That's the slope over there. Now since I have the slope, I can use the slope and the point given and substitute those in the point slope formula right there. Instead of the y, I'll put the y that's given, which is negative 2. Instead of the m, I'll put the slope that I've calculated, 7 over 6. Instead of the x1, I'll put the x that's given in the question, which is 2. Again, solve for y, so I'll have here y plus 2 equals to 7 over 6 x, and 7 over 6 times negative 2, which should be 14 over 6, simplified as 7 over 3. Moving plus 2 to the other side, and I'll have y equals 7 over 6x, negative 7 over 3 minus 2 should give me negative 13 over 3. and that is the equation of the tangent to the line. Now try it out.